So we're going to talk about how to parallelize within a for each batch when you're doing Spark streaming. The reason usually people want to do this is they have to use for each batch and they want the writes to happen in parallel because they want lower latency than what they are getting. For example, when you are in a for each batch and you're writing, say, 4 tables, just an example, you'll do that sequentially. That table 1 would finish, then table 2's write would finish, then table 3 and table 4 and so on. Right now, because these things are happening in parallel, you are going to end up with higher latency, and sometimes we don't want that. What we really want is these writes to happen in parallel. So in this video, we're going to talk about how can we achieve that. So what are we going to use special is basically we're going to use Python threads to do it. We're going to use the concurrent futures library to achieve it. So let's go through the code once. So let me do that. Okay, so in the start we have our bunch of imports. We have our catalog database target. So this is where we are going to write to. And then we have a source. Our source is a delta table. You can choose something else, doesn't matter. And this is our streaming source data frame. So again, this could be Kafka, this could be Kinesis, or this could be S3, this could be ADLS, or this could be Delta. In my example, I'm using data frame. Also, one more option which you have, and you have similar options in Kafka and Kinesis, which is you can control the size of the micro batch. Like how big is the size of the micro batch can be controlled by a parameter called max files per trigger. The default is 1000. I'm doing 500. For Kafka, it's called max offsets per batch. This basically controls the size of the micro batch going inside the for each batch call. Okay, so now we have a streaming source. What do we do next? So then I have written a function which is going to write data into a delta table, and this particular function would be run in parallel. So that's my example. Again, you can write your own function, doesn't matter, but this is the function which we are going to run in parallel. That's all what you need to know. So in this example, I am getting this input data frame, and this input data frame I'm filtering by certain things and then creating my target data frame which I want to write. So in my example, my upstream had data for 4 tables, and now I'm demultiplexing them. That's what I'm doing in this example. That's what we have. And then what we do is we create a for each batch class. The reason I'm using a class is because I want to parameterize. If you write a regular function, you won't be able to parameterize. But if you write a Pythonic class, then you can basically pass any values to your for each batch. So here I'm just passing catalog database. You can pass other variables too. And then this is the function which you need to pay attention to. This is called process microbatch. Again, this is custom UDF. You can write whatever you want. What really matters is this function gets 2 inputs, which is your microbatch data frame. You can't change this, by the way. You get a microbatch data frame and the batch ID. Those are the only 2 inputs allowed. Now, because you might want to pass more inputs, that's where this class comes in, because class can have lots of parameters or variables. So what do we do inside this process microbatch? Again, you can do anything. What I'm doing is first I'm caching my microbatch. The reason I'm doing it because I'm going to run different actions. So I'm going to run 4 actions. I'm doing 4 writes. So in my example, I'm going to access this microbatch 4 times. That's why it's best to cache it. And then once you're done processing, you should uncache it or unpersist it. So again, going back to my example, I had 4 types of devices in my data. And what I'm trying to do is write to these 4 tables in parallel, or say for these 4 devices in parallel. So here is where I call my function, which is called process table. So let me show you the function call. So here I'm saying create a thread pool, and I'm only creating 2 threads at a time. Now you can change this number 4, 8, 16. Be cautious of it. Don't take it too far. For my needs, I set it at 2 because I wanted 2 tables to be written in parallel. I could do 4 also. I could do 8 also. Depends on your hardware, right? So for the sake of this example, I'm going to do 2. Again, your latency would define how many threads you should be using. Okay, so what we do is we call this function called process table, and the function call looks a bit different. It's not something which is dependent on PySpark. This is dependent on Python itself. So what we are doing is we are calling this function process table and then passing these parameters. So I'm passing device type, batch ID, catalog database, and the microbatch data frame, right? So these are the things which we are passing, and then this is in a loop. So when this code runs, basically you'll have 2 threads being 2 threads being created and 2 threads finishing at the same time. Or sorry, 2 threads being initiated at the same time. Again, if I do 4, then all 4 would get initiated. And after this, Now I launch the thread. Now I need to wait for them to finish. So which is this line. So this will ensure that I wait for my threads to finish and give a response back. Now some of these threads would fail. They may fail, which so what I'm doing is rather than failing the whole program, I'm just collecting all my exceptions first. And then if any of my threads fail, then I fail the whole micro batch, which makes sense. That's what we have in the code. This is the instantiating call, which is I had created a class, now instantiate the class. And how does everything come together? So remember we created a streaming data frame up in the code above. So that's what we have. Then we have write stream call. Then we have a available now call. Available now means once the backlog is finished, the stream terminate. We have a checkpoint location. I have a temporary checkpoint location because I'm experimenting, but you should have a static checkpoint location. And then I give my streaming query a name. And this is the most important piece, which is I use this special function called for each batch. And then I provide which function to call. So I'm calling my function called process microbatch. Now let's see the code in action. So run all. By the way, if you're always testing, I always use this thing called clear state and outputs. This basically removes and clears all variables. And then I do a clear state and run all. So that's how I do things. So now I just ran all, the stream has started, or sorry, the stream is initializing. So in a couple of seconds, we'll see it fail. I'll tell you why. Log. It's sitting empty right now. There is nothing here. So let's wait for it to run. I have only 4 cores, so it's a light machine. So it failed, but it's expected. I'll tell you why. But let's look at the output first. Writes to 3 of my tables succeeded, and you will see all of them same time. Given I did 2 threads in parallel, 2 of these commits would have happened first, and this one would be slight delay. I don't know how to show the seconds part, but I have verified it offline. So you can see the tables got created at the same time, right? Now, why did it fail? So I wanted it to fail. Let me show you. So what I did was I wanted to prove that if one of the thread fails, the whole micro batch fails. So what I did was I self-inflicted an error, which is I provided a bad table name. I put dollar in the table name, which is not allowed. So let's look at the logs. Let's look at what's here and let's also look at the driver logs. So see, it's saying, hey, syntax error and it's complaining about the dollar sign. So that's what we have here. Let's see. I want to take you to the driver logs now and show you what things look like there. We're going to driver logs. So I have written print statement, so my errors would come in the print statement. So this is what I did. So I'm saying processing batch ID 0, and then you would see 2 calls. Processing table for device type controller, processing table for device type gateway. So these 2 started at the same time. You can see I have put timestamps in my print statement. So 2 writes happened at the same time, started at 3:49, and then we finished writing for one table. And then we started the writing the other table also, which is sensor and actuator. And then I said, okay, exception occurred while processing device type. So this is an example where if one failure happens, the whole for each batch is going to fail, but the other 3 will successfully exit. Which means if you have a append use case, you might see duplicates. And to handle that in our code, we have given this example. So these parameters helps us avoid duplicate conflicts. You should read the documentation. I'll add a link to the documentation. This is a special parameter, but I don't want to digress and just start talking about this one. Now let's remove the fake error which I created. Let me do that. So it was in my, yeah, this function. This is where I self-inflicted an error. So let me remove that. So once I remove that and run this code again, essentially we shouldn't have any failures. The for each batch should actually successfully start writing to all of the tables in parallel. So it's going to initialize again, and we should see writes to 4 tables running in parallel soon. Let's see. The first initialization always takes some time. By the way, if you don't know about query name parameter, this is a good way to give your stream a human readable name. I'm calling it parameterize for each batch, but you can call it anything you like. Okay, it's working now. Nice. So if you look at it, now that it's getting us a name, these graphs is going to pop up. And if I go to the catalog, now you should see 4 tables. Okay, so we have 4 tables, and then we can look at the table history to see if the writes are happening or not. So the first write is happening now, which is at 3:08 p.m. And let's look at the other table again. Let's look at history. And now you see writes happening again at 3:08 p.m. So now the stream is just going to continue running and tables are going to be created. This is writing 315 rows a second, and I'm running on a very tiny cluster. And whenever, by the way, you're doing streaming, just pay heed to this parameter, number of files outstanding and bytes outstanding. For any streaming job, these numbers should continue to drop. The reason is signifies that the speed at which the source data is getting created, we are able to keep up with it. So always you want these two numbers to drop. And yeah, in my case, you can see that I'm not sure if they're dropping or not, but essentially if they're not dropping, I just need to increase my batch size. So my case is dropping. So it was 684, now it became 212. And process rate is greater than input rate, which is good. And now I'm able to do write to 4 tables and my latency is 23 seconds. But again, any of these things can be altered. And because we were using available now and have processed all the backlog, the stream stopped. It's what we want. And yeah, that's about it. I'm going to commit this code to GitHub and I'll add a link to the code in the description. But yeah, let me know if you have any other questions. Thank you.